Hi, I am Rajat Taheem and my paper for STC 2016 is Performance Testing in IoT World. I'm into performance testing since more than 11 years. However, this particular case study gave me a lot of learnings. So I thought STC would be one of the platform where I can share my experience working on performance testing of IoT World. It is no brainer that IoT has been picking up in last couple of years a lot. If you talk about wearables, it has surpassed the sales of mobile devices. People are using wearables for their fitness tracking, for their health tracking, or various personal uses. If that's not it, there is a special industry that is booming up, which is using wearables to monitor people or patients with critical illness. It has been thought that by 2020, around 4 million patients would be globally monitored. So this is the beauty of wearables, that it can not even monitor your health condition, but based on your historic information, they can take decisions or can feed the decision makers with information so that decision makers take a right decision towards your health and towards your wellness. So let's talk about one of the particular case study. So the person in black t-shirt had undergone a critical heart illness due to which a CRT was installed on him. Now this CRT device is capable enough to give electric shocks to the patient if it senses that heart rate has gone down or there is no heartbeat at all. Just an attempt to revive the patient. If that's not all, the patient was also asked to wear a Fitbit, which would monitor his heart rate, which would monitor his blood pressure, which would monitor his physical movement, his sleep activities, and would prepare various charts for the consulting doctor and the dietitian. So consulting doctor can take right decision on what medications has to be prescribed to the patient, and dietitian can be informed what kind of cooking should be done for him. That information was fed to the robotic cook, and the poor guy had to eat whatever the robotic cook cooked for him. So that was a good part. But let's talk about the area of critical illness. Let's visualize that once he gets into an attack, or once he get into the condition where he is not able to respond to CRT. So the this CRT device and the Fitbit would immediately talk to this app installed on his mobile device, and we are not capable enough to revive the patient. And the mobile app would immediately talk to the nearest hospital to dispatch the ambulance. Ambulance would talk to the mapping service and would get the most optimum route to the patient. Yeah, if that's not all, before the patient reaches the hospital, the app has talked to the insurance industry, got the first premium towards the hospital. So the before the patient reached, his payment has reached the hospital. His standby doctor is present with his historic information, and his bed is reserved in the hospital. And lastly, this app would install is ICE contacts in case of emergency contacts. The so and so thing happened, and the patient has been admitted. So this is a situation, and since this is a life-saving, mission-critical app, this can actually make or break or can save a life. This testing of this particular app becomes of prime important. Earlier, when I went into this kind of situation, I thought it would be normal testing areas for IoT, like functional testing or performance testing or availability. But as and when I moved ahead in this area, I found that this is not just normal performance testing or normal app for performance testing or normal apps related concept. This is beyond it. So CPU and RAM utilization did play a role, but other aspects also play a major role in the performance of this particular app. Since, for example, device temperature, bandwidth utilization, battery utilization, storage utilization, based on this data, the device can actually terminate an app. And if the life-saving mission critical app is terminated, there is no way the person can be or the whole system can work. You can lose a person's life with that. So testing these aspects becomes prime importance for particular case study. Let's relook at the data flow. So there is an app that is installed on the mobile which talk to variables, which can talk to CRT. It can talk to variables on CRT based on Bluetooth range, or it can use Wi-Fi facility to talk to them. It talks to various cloud services through internet, and it can even talk to the ICE contacts, as in it can give the data of the patient to the ICE contacts through SMS, or maybe it can create a report if the ICE contacts has downloaded the app, the receiving ad. They can open the app and find out the reports of how the patient is doing for last 1 week, 1 month, same what the consulting doctor can see. So the heart of the entire system is an app that is installed on the mobile device. Let's see the challenges. What kind of challenges we can see in performance testing of this particular app? Hardware and software combination. Since this app can be installed on any kind of hardware, it can be a MediaTek family, it can be a Snapdragon family, it can be an Apple family, Samsung family, which can have their proprietary CPUs. It becomes immensely difficult for us to predict on what device it would be installed, and how the device would react to particular app or particular situation. So testing various permutation and combination could be was the first performance testing challenge for us. Next was testing the positives. For most of the performance testing case studies I had come across, we had mostly done the positive testing. We were not really concerned about the negative testing, as in what if the failover testing kind of thing. What if particular service goes down? What if during an emergency the app is not able to talk to the ambulance service? What if during the heart rate, or during the issue where the heart rate goes very low, the CRT is not able to talk to the mobile device, and it is not able to inform whether I am able to revive the patient or not revive the patient. So what should the app do? So negatives based on various cutoffs from various cloud service becomes very important in this particular case study. Any kind of slippage can lead or cost a life in this particular system, and hence performance testing at various angles becomes prime importance. Similarly, data that is transferred between app and various cloud services, it has to be minimum, so that even in the low speed areas the data gets transferred. If the data is higher, it becomes very difficult to establish connectivity during low speeds or intermediate connectivity. What if the emergency comes up during the intermediate connection or during 2G connections? So that data transfer speed or the data quantum becomes a prime importance in using this app. Another major challenge that we came across in this particular case study was performance bug lifecycle. If there is a bug that came up, who owns that bug? Since there are various cloud providers, various kind of hardware and software providers, it becomes very difficult to find out who owns the performance bugs and how do we fix it. Has everything to be dumped on the app? What if a new hardware or new cloud service comes into picture? Would you adjust the app, or would you ask the hardware manufacturer or the cloud service to adjust their environment? Similarly, the development methodology, since more and more people are moving towards DevOps or agile kind of methodology, the time window to do performance test or to do test becomes very less. So within limited time window, you have to do a performance test, you have to produce results, you have to ensure that we cover most of the scenarios, we cover negatives as well, becomes very difficult. So let's see how did we manage to cover all these challenges and were able to understand the criticality of the app, but still produce results. So this was the approach that we followed. The approach was we created performance test requirements before we created the app. So once the performance test requirement were created, we created a prototype of the app. This app prototype was nothing but simple blank screens and some dummy flow that was happening without any logic, without any validation between some stubs and drivers acting as cloud services. And we tested this particular prototype on various devices or at various conditions to find out how the basic setup is behaving. If something that can be rectified at the basic setup level itself, or if something that became changed at the basic setup itself, it can save us the entire life cycle. By prototype testing, we found out we were able to modify few technologies that this particular technology is not supporting on various devices. Let's use this particular technology and then create a prototype. So this prototype testing, which lasted not more than 2 or 3 weeks, we were able to find out which was the best possible way to create a design of this app. Once that was finalized, we created a design of the app and created a first functionally stable version. We had a different team for development and performance testing. Once the first functionally viable version was available, we tested this version extensively with various devices and various conditions to prepare a table as compared to the baseline report. What did the table say? That if I install this app on MediaTek family with 3 GB RAM, 3G connection, this is response time of various services. If I installed it on Snapdragon 64-bit, 2 GB RAM, 2G connection, this is response time. So I have a baseline, I have a delta response time at various possible permutation combinations which I needed or which were prioritized. Once that is done, we went into the development cycle, normal development cycle or the enhancement cycle where actual development happened. So each time a functionally stable environment was available, all that was required was do a baseline test. Since we all have a delta for various conditions, we just use that delta to find out what was the variance at each level, and what like for a very example, in third sprint we found that for particular Apple model, this response time was going way too high for one of the two reasons that we had. So we fixed that immediately in that particular sprint without even actually testing the Apple device. So this particular whole approach helped us do performance testing in least possible window. And since it was possible in 1 week to do a performance test, create a baseline report with various devices with various permutation combinations, the performance backlog was quite healthy. We were able to do performance test after every second sprint, and we were able to create loads of data for the developers, for the application owners, to understand how the application is behaving, or are we actually meeting our target or we are deviating. Finally, once the final version was available, we tested it extensively with various devices. This time, apart from simulated tools, we used actual devices. We asked each and everybody on the floor to bring as many devices as possible to the office. So it was like crowdsourcing for the whole day. Bring your own device, maximum possible devices. We did a performance test with various permutation, live permutation possible, and of course with the simulation to find out how or where the delta can be or should be adjusted. Accordingly, this delta response time were adjusted, and finally the application went live. So once the application was live after 3 months, once there was a major release to be done based on various feedback we had, or different condition that we ran into, all we did was we used this delta variance, the updated delta variance, and we were through with the performance test as soon as possible. So the whole approach was performance based. Performance was the backbone, and the deltas of various devices was the key to drive the entire performance testing approach. To summarize, early environment was a focus. Bring your own device really helped, and performance driven development approach was the approach that actually helped us drive the entire difficult stuff, difficult performance testing case study for us. So that's all from my side. I'm Rajat Taheem again. You can find me on LinkedIn at the given link. I'm available on majorly on all social media platforms, and you can Google search me